Hello, Professor. My name is Deven Chandel. Here is my group partner.
Hey Professor, my name is Mohiyuddin Khatri.
So in this video, we will be going through the live demonstration of our project Smart Plant Care System. I will be going through the demonstration on how the project is working, and on my circuit diagram in my laptop I will be going through the brief description on each component, and my partner here will be.
And further, I'll be showing the presentation, going through the slides, and also I'll be explaining code and how the code works on our demo project.
Hello everyone, my name is Deven Chandel. Today I am excited to present my project, the Blynk IoT Smart Plant Monitoring System. We will start by introducing the components, explaining the purpose, and then moving on the live demonstration on the system in action. Let's begin by explaining each component and its role in the system. First of all is the ESP8266. This is the heart of our project. It connects to the Wi-Fi network and communicates with the Blynk app, allowing us to remotely control and monitor the system. Second is the soil moisture sensor. This soil moisture is connected to the analog pin A0 on the ESP8266. Its role is to measure the moisture level in the soil. When the moisture level drops below a certain threshold, it triggers the water pump to ensure the plants get enough water. The soil moisture sensors are crucial for maintaining the right moisture balance in the soil, which is vital for the plant's health. Next is our DHT11 temperature and humidity sensor. This temperature and humidity sensor is connected to the power through the ESP8266, and the data pin is going at D4. So the sensor measures both temperature and the humidity of the system, providing us essential data to ensure the plant's environment is optimal. By monitoring temperature and humidity, we can take preventive measures if the conditions become unsuitable for the plant. Next is the PIR motion sensor. Here, the PIR motion sensor is connected to D5 of ESP8266. Its purpose is to detect any motion around the plant, and it will show the motion through the Blynk system in our app or in a website on a laptop. The PIR can help us to detect motion in the environment for any disturbance, ensuring the plant's safety from any external force like an animal or some other beings, human beings being there, or any disturbance to the plant. Next is the relay. This component is pretty important in the project, as the relay acts as a switch, allowing us to control the higher power water pump. This water pump with a low power signal from the ESP8266. As you know, a relay is necessary because ESP cannot provide supply that is required to turn on a water pump. It only gives us a small voltage that switches and allowing the battery to connect to the water pump and turn on the pump. So next we will talk about the water pump alone. The water pump is connected to the relay module. It is responsible for watering the plant whenever the threshold is low. We have the automatic watering system, which really helps the plant to maintain a certain moisture level, helping it to be in a healthy environment all the time. This is our I2C16 by 2 LCD. The LCD is connected to the ESP directly at D2 and D1, showing the real-time data on temperature, humidity, soil moisture level. It provides us a quick and easy way to monitor the system locally. If you don't want to go through your Blynk and you're already at home, you can check the status on the LCD. Then we have a push button. We can use this push button, which is connected to the D7 on the ESP8266. This allows us to manually control the water pump and providing us a flexibility to water the plant manually if needed. This is like an extra layer of functionality for the user if they presume. Now we will go to the next part, that is the live demonstration.
Hello guys, Deven here again. So now we're gonna do the live demonstration to show you how the system actually works in real time. Let's just go through where each component is located to make yourself familiar with the system. As you know, this is our brain, the ESP8266. Next up, here we have our PIR motion sensor. This is the I2C for our soil moisture sensor, which is directly under the soil. Now here up is the relay on the left, and the top is the DHT11 soil temperature and humidity sensor. We have our motor right here. This is our LCD, which is giving us temperature, humidity and soil moisture. M stands for motion, if the motion sensor is on or off. W stands for the water motor, if it's on or off. Here is our Blynk app showing us all three sensors reading and the status on the plant. You can toggle through the water pump and toggle through the PIR sensor. Here is our plant care website, also the Blynk website, which you can go through and just toggle through everything if you want. It's the same as the app. Okay, now I have told you each components where they are located. So now let's move to the live demonstration on how each of the components works in real time. First, the soil moisture sensor over here. Okay, as you see, the current moisture level, which is here, it is about 33%. So when this moisture level drops below the threshold, the relay is activated, turning the water pump on. So let's demonstrate this simulation by simulating a dry area. I will pick this up, which will turn on the motor, giving the whole plant water. Okay, let's pick it up. So as you saw, the motor turns on and the pump automatically turned on, and the notification was sent to the Blynk app. I will show you that notification right here. So right here it shows soil moisture is low, water pump turned on. Even this is just the app. We can even get an email notification right here showing us the same message. Soil moisture is low, water pump turned on. Next up is the DHT11. So I cannot stimulate the temperature as I have no means to show more than 830 degrees. I can demonstrate what happens when the humidity is more than 80%, which is it is 86 right now. See? So now we will go to the notification bar. Here you can see it is saying that the plant has more humidity and we need to give it proper ventilation, and the same we will get a email notification on that too. So now we will go to the next sensor, which is the PIR motion sensor. So for that to work, we need to actually turn on the PIR motion sensor right here. If I click it here, now the PIR sensor is on, and if I give any motion near the plant, the LED is turned on, telling there is some entity near the plant and need to take care of it and all that. And we will go to the real-time display. I have already showed you. The real-time data of the temperature, humidity, and soil moisture is continuously updated in the LCD and in the Blynk app. This allows for easy monitoring of the plant's environment, both locally and remotely. The water pump can be controlled based on the soil moisture level or manually using the Blynk push button or the push button on the breadboard. Right here, if I press it once, it will turn on the motor. The same will be happening if I turn it on here. And if I go here on my laptop and turn it on there, it will turn on here too. See? So because they are both connected to the same ESP. Now we will go in much deeper. I will tell you how actually each of these components works. So let's move to the soil moisture sensor. The soil moisture sensor works by measuring the electrical resistance between the soil. So when it has a low resistance, it will tell the soil has low moisture, saying the moisture level is low. Next is DHT11. So DHT11 sensor is a basic low-cost digital temperature and humidity sensor. It uses capacitive humidity sensor and a thermometer measure to measure the surroundings temperature and give it to digital pen. So we have set the threshold for the humidity, which is 80%. For temperature, it is 30 degrees Celsius. The PIR motion sensor, on the other hand, detects the infrared radiation emitting by a moving object. So whenever there is a motion, it will be sending data to the ESP, telling it to turn on and showing that there is a motion. Next is when I think that is the most important component as a safety reason. The relay we are basically using as a switch because you know the ESP max output is about 5 volt and 3.3 volt. So in that much voltage you can't really operate the motor. So we need a higher voltage for it. So that's why relay works as a switch. So whenever low voltage is applied to the relay, it turns on the switch on the relay and allowing the battery to give the power to the motor and turning on the motor. So next is the LCD. The LCD provides us the real-time information. I think I've told you this multiple times. And it is like a helpful thing. So if you're at home and you don't need to always open your app and check it, you can just go over there and see in your LCD and you will see that yes, I have this much moisture, this much temperature, and I need to wash it or not. But if you're outside in your office, you can check it through here, through your app, through your laptop. So in conclusion, our Blynk IoT Smart Plant Monitoring System provides a comprehensive solution for plant care. It combines real-time monitoring system, automatic and manual controls. The remote alert is most important feature. So you will be alerted if anything is wrong with your plant. If temperature is too high, humidity is too high, soil moisture is too low. And that's it for the demonstration. Thank you for watching and
Hey again. So now I'll explain my slides for the PPT and go into much detail of the project on the written side. As you can see, this is the information page of team members being me, Mohiyuddin Khatri, and my friend Deven Chandel. And here's our contact information as well. So the next slide, we can see this is a welcome slide with our motto of nurturing nature with technology. Here you can see a brief of the project, but we will go into much detail soon. Next, we have to straight jump into the components used for our project. And first, we have to talk about the heart and brain of our system, that is ESP8266 microcontroller. This microcontroller helps us wireless connections and integrates all our components. It's highly power efficient. A key feature of this device is that once set up, it just requires a power supply and a designated Wi-Fi connection to do its job, making it truly IoT worthy. Here we get our soil moisture sensor. On the left side is the picture with the pin out of the component. As mentioned in the slide, this underground sensor is near to our plant roots, taking real-time information of the soil moisture levels. Further, it alerts the brain of the system when the moisture level gets below 30% that the plant is thirsty and we need to pour in water. Also, it alerts the brain again for overhydration for moisture level about 30%, again saving the plant's life. Now we have DHT11, a multi-purpose small fellow. This device is always around our plant monitoring system, and it monitors the temperature and humidity of the surroundings so that our plant don't get sunburns nor it gets any fungus. Just like the soil moisture sensor, this also sends real-time information for too much high temperature and too much humidity. Now we go to the most active part of the system, that is the PIR motion sensor. This, when turned on remotely, alerts the user on their Blynk app if it detects any motion or any activity going around the plant. This is a perfect integration for those who like their plants to be free in the outside world and still wants to protect them from the threats like birds and cats. Next, we are going to talk about the automation of our water pump. See, the water pump don't just start by itself, but once the threshold of 30% is not met, then our system brings orders the relay module to turn on the motor immediately. This is true otherwise as well. That is, when the soil moisture is equal to or greater than 30%, then the pump is ordered to stop pouring any more water, hence keeping the controlled environment. Here is Blynk. We are using this to remotely operate our sensors and get all the data. This technology also helps us to get alerts for high temperature and humidity directly on our phone through phone notifications and also via email. This really narrows down the need to have fancy stuff around the plants like barbed wires and shields, as this also can give information if any motion is going on around our potted friend. This here is the LCD screen connected to our smart plant care system, and this is so that the person who don't have access to the Blynk dashboard but is near the plant can still have the real-time data of its surrounding and needs. This is also helpful in case if there is some error in the automation or else if the IoT servers are down. In that case, this manual information will be much helpful. Next up, let's talk about the relay module, which plays a critical role in our smart plant care system. The relay module is responsible for safely controlling high voltage devices like the water pump. It acts as an electrical switch that isolates the low power microcontroller from the higher voltage required by the pump. This ensures that the microcontroller can control the pump without risking damage from the high voltage. The relay is triggered by signals from the ESP8266 microcontroller based on the soil moisture levels, enabling efficient and safe operations of the watering system. Now, let's bring everything together by discussing the system setup. This is where all the individual components like ESP8266 microcontroller, the sensors, the relay module, and the water pump comes together to form a fully functional smart plant monitoring system. First, the sensors are strategically placed around the plant to monitor key parameters like soil moisture, temperature, humidity, and motion. The LM393 soil moisture sensor is placed near the roots to accurately detect moisture levels, while the DHT11 sensor is positioned to capture ambient temperature and humidity. The PIR motion sensor is placed where it can detect any movement around the plant. All these sensors are connected to the ESP8266 microcontroller, which serves as the brain of the system. The ESP8266 processes the data from the sensors and make real-time decisions, such as when to activate the water pump based on the soil moisture readings. The relay module acts as a bridge between microcontroller and the high-voltage water pump, ensuring safe operations. The system is powered through a reliable power source, which could be a battery or a direct power connection. The ESP8266 is connected to your Wi-Fi network, allowing the system to communicate with the Blynk app, where you can monitor and control the system remotely. Finally, the LCD screen is installed to display real-time data right at the plant's location, giving you immediate insights into the environmental conditions. Once everything is connected and powered on, the system automatically starts monitoring and managing the plant, allowing you to focus on other tasks while ensuring your plant gets the best care possible. This block diagram illustrates a visual representation on how the sensors provide critical data to the ESP8266, which processes the information and controls the water pump via the relay module. It also shows a manual button connection in the system which can be used to control motor in case of a server down or similar situation. It also shows an external high voltage power supply for the water pump. The system also offers a real-time monitoring through the LCD screen and remote access via the Blynk app, making plant care both effective, efficient, and user-friendly. In this slide, we learn about temperature thresholds. Temperature threshold in itself is a very interesting topic. In simple words, the temperature threshold is the temperature just below which the respective plant experiences peak growth. For the plant which we are taking care, it happens to be 15 to 24 degrees Celsius. That's why the temperature alert we have set is 30 degrees Celsius to cope up with extra humidity, if any, around the plant. Because the temperature threshold is a variable for different plants, we have set the system to be easily customized with the temperature threshold of the plant which the user decides to take care of using our system. Next up is the humidity threshold. Similar to the previous slide, humidity threshold is the humidity just below which the plant thrives the best. As mentioned earlier as well, our humidity threshold is 80%. Similar to before, this value is also not constant across the different species and thus also easily adjustable. This slide again talk about the power of automation with the water pump. But few details which are different in this are the mention of threshold and how the moisture sensor actually goes above and below threshold, and then the ESP is sending signals whilst the thresholds are met. This slide walks us through all the data which is provided in the LCD screen. As mentioned, on the top half of the screen, we get the real-time temperature and humidity levels in percentage, and in the bottom screen, we can see the soil moisture level along with on-off status of both motion sensor and water pump. Let's talk a bit more about our dashboard, that is the Blynk app. Along with the real-time monitoring of all the data, we can also store and review the history in our app, which helps us track the health of our leafy partner. It also gives us an option to set custom alerts for specific information such as a specific threshold or a specific alert of the motion sensor. So as mentioned in the threshold slides before as well, our systems are really scalable and they're not restricted to just one particular type of plant, but they are expandable to all different kind of plants with customizable temperature, customizable humidity sensors and everything. And as mentioned here, we can use the system for zone irrigations, and we also can use it for individual plant profiles. And we have a really good centralized dashboard which we can use for indoor gardens and stuff. Here we talk about low power consumptions and basically the need and the use of our system in specifically for using less power to save energy in longer run, so that a simple plant which we actually plant to benefit nature doesn't turn out to use too much energy and in turn doesn't waste too much energy. So that's why for the first at the first place we are using ESP8266, which itself is a low power consumption system. Also we can implement sleep modes that which is again customizable directly from the Blynk app, and in which we will just turn it off to the sleep modes when we think that we don't need it. And we can also integrate solar power in that, so we don't have to use any external power supply to give the extra power, so that we can save power supply from there as well. And at the end we need an effective data transmission, but with the use of ESP8266, again it goes to a really minimal power supply for doing all the data transfers as well. This is an important slide where we can see the troubleshooting of our components and some of the instruments and Wi-Fi and stuff, and we can see that we have some common issues and the solutions to it as well. So as mentioned here, we have some issues as inaccurate reading and possible cause for which can be sensor calibration, which for the solution we can just recalibrate sensors using the known references and so on and so forth. We have these troubleshootings, and we can also make a website for specifically our app and our system, so that our users can just directly go to that website and directly have these troubleshootings and the solution to itself for the common issues found. This slide talks about data logging and analysis. According to me, this slide is pretty much self-explanatory, but if we again see, we can see that we use continuous data collection, which we have talked about in the previous slides as well, that we collect data continuously from the humidity and soil moisture sensors and everything. We have the cloud storage set up with the Blynk cloud, and we also can set up Google Sheets to store the history of these moisture sensor and all the data for easy accessibility. We can go further and have some setups for trend analysis, which again will be a further step for automation. If we want to do that, it will be really helpful for self-healing plants, and we can set up some medicines and stuff for specific plant problems if the trends are seen, or some specific alerts especially for these problems, so that we have an early knowledge of any problem which starts occurring, or any fungus or stuff which start occurring to our beloved plants. So here we see that what environmental impacts we are having, and what environmental impacts we are having in mind to conquer from this smart plant care systems. As discussed in further slide as well, and we definitely have energy efficiency. We are using low power components, and which in turn will reduce the carbon footprint, and which in turn will give us more oxygen for the plants and a healthy future. And also we can see here that we are trying to do water conservation, as we know that water is a very important resource, and in today's world we need to conserve water as much as possible. For that we have this automation as the main goal, so that we can save as much water as possible. And further going, we are trying to reduce chemical use. So basically, how the chemicals work is it boosts up the needs, it boosts up the plant to thrive in the conditions which it's not supposed to be in. But by keeping the plant in its optimal conditions, optimal temperature, optimal humidity, and with the good balance of water, soil, moisture levels and stuff, we are reducing the wants and the needs of chemical usage for our crops and also for our plants and stuff. So in turn, it will give us longevity. In turn, it will give us long-lasting effects on our plants. It will grow really good. And as the last point is, we have the longevity in repairs as well. So the systems, a modular design allowed for easy repairs and component replacement, the lifespan, and reducing electronic waste. So that's the same thing that we are using light components. So it's really easily replaceable, and they are not that environment affecting components which we are trying to integrate in our system. At this point, we can talk more on the enhancements which we can add in future. So talking about plants, so basically we can integrate AI-powered plant recognition. That is, we can get AI system, machine learning system integrate in the plants, and we can have a big system which will be connected to all the plants at the same time, and we'll have set up some sensors, and we can set up some cameras which in turn will be connected to our MLs, our machine learning algorithms, which will study the plants, which will study what type of crop it is, and it will automatically set up the temperature, humidity and stuff. And also we're talking from some slides before about the self-healing plants. So this AI powered plant recognition can also help in that it can have that real perfect solution for that plant automatically without any human interference in that. And further, as you can see, there's spectral analysis, and we have automated curing, and we have harvesting, and we have all kind of sections and microclimate creation. So these are far-fetched enhancements for this level of system right now for us, but we definitely plan that if we get in the business properly, then we definitely plan to have these enhancements for the next 5 to 10 years, which can actually change the irrigation system of our crops and for our farmers and everyone. So technically, we are at the last slide of our presentation, and this slide you can see the commercial applications, that is beyond home use. So first and foremost, as I already talked about the agriculture, so we can use it for greenhouses and small farms, and have it for detailed crop. It can be also used for research institutes, which can help scientists to study more precisely about the plants, and which in turn can give us healthier plant options, and which I believe studied in a proper way, then we can have some a new species of plant which will be enhanced in more features which we require. If we need more fiber, we can set it up, but we need to, for monitoring that, we can use the system. And going further, we can use it for urban gardening as well. as I said here, that we can use it for develop socialized versions for rooftop gardens and vertical farms in cities. So, as if you might have this in your knowledge that these vertical roofing and irrigation is done in so many farms and so many villages, but we don't have it in our cities because we are so busy and everything, right? So using the system, we can actually have the vertical farms in our cities, which in turn will again increase the level of crop, which increase the quantity as well, quality of the crops and other natural goods, so that we can have it more available, which in turn will also affect our economy and which in turn will also reduce the prices for these in the local markets. This is just a contact slide having the name of our project, that is Smart Plant Care System, with my name, Mohiyuddin Khatri, my email address, my phone number, and my partner's name, Deven Chandel, his email ID and his phone number. And for the official last slide, we have the first slide as the project's requirement, same as the first slide and last slide. So again, we have the same thing. We have the name of our project, that is Smart Plant Care System, our course name, that is TPJ655 Final Project Presentation, and the presenters again, which is me, Mohiyuddin Khatri, and my course is Computer Engineering Technology, and my email ID and my phone number again, and my partner's name is Deven Chandel. His course as well is Computer Engineering Technology, and he's also a student, and his email ID and his phone number is also provided with the name of our college, Seneca College, and the date on which this presentation was created. Thank you so much.